Given the graph of y equals to 7 log x, how do we use this graph to solve the inequality? The key to do this, to match one side of the inequality, this part, with the function on the graph, that is, this part. We start out with the original question here. Then what are we missing? We're missing the 7 here, right? So then we multiply 7 on both sides, which gives us 7 log x greater than or equal to 4/5. Now we have successfully matched this part with the graph, and because this is actually the y, and what this is actually saying is where on the graph would y greater than or equals to 4/5, and the where actually means by which values of x. So just like solving equations graphically in our previous video, we add the straight line of y equals to 4/5, this one, to the graph. So in other words, we're drawing this line here. It's a horizontal line equals to 0.8 here. But the only thing different is when we did equations, the answers would be some values, right? But now when we're solving inequalities graphically, okay, the answers would be not just one or two values, it would be ranges of x. Now, because we're looking for greater than or equals to 4/5 for the y, that means we're looking for this part of the graph. And this is true only when the x values are greater than or equals to 1.3, right? And so we write this down here, the solutions of this, and i.e. the original question here. And so the answer is x greater than or equals to 1.3. Now for this question, for part A, we want to find the value of k, which is an unknown missing in the function. It's a constant. So how do we use this graph to help us? This part is easy. You can just pick any point on the graph and just put it into the equation. Then you can solve for k. But which points are easier? Then I will actually pick this point, because the calculation will be the simplest when x equals 0. So from the graph, when x equals 0, at the same time y equals to negative 1.0, correct to nearest 0.1. Why 0.1? Because each unit here will be 0.1. And so we put 0 into x and negative 1.0 into y, and then we solve for k. Now part B. Okay, we want to solve this equation by using the graph here. So using our results from part A, the function would be this. And now we need to match this part with the equation of the graph here. So we start out with the equation here. Then I move the 2.3 to the other side, and I'm missing the negative 1. So I minus 1 on both sides, and so I got 1.3 on this side. And so I draw this line here, and coincidentally, the root is also 1.3. And notice that if the line is a little lower, then we may have more than one roots, of course. Part C, solving this inequality. This time we're going to match this part with this part. Then you look at the coefficients. As you can see, we need to divide each of the coefficients by 2, okay, except this part does not match. So the constant, we need to do something else. But first, by factorizing out the 2, at least these two terms are good. And so 0 divided by 2 is just 0. Then I move the 1 to the other side. Now because I'm missing this negative 1 here, I would minus 1 on both sides. And so now I have this greater than or equals to negative 2. So then when I add the straight line y equals to this number right here, then you see there are actually 3 intersections. Now because the inequality is greater than or equals to negative 2, then you have to ask yourself which part of the curve lies above negative 2. Then actually this is referring to this part and also this part, and so on. And so the range of x would be somewhere between negative 1.2 to 0.2 and from 1 and all the way upward. So these two parts will be the answer, but don't forget the or.